in the second figure. In the first figure, showing a single shear is one area of resisting. Then the second figure shows this how we conduct the double shear. The standard Indian code for conducting the shear test is IS 5277 method of test for determining the shear strength of metals. So this is what is happening. So before the test, we are holding the two portion of the ends of the specimen, and we are applying a center load which will allow the specimen to shear off at these edges. Okay, after the test, the center portion will be split or separated from the ends. So the calculation include is we are measuring what is the load that is. So you know what is meant by UTM, in which we have seen two tests on UTM in which we can measure the load, means the dial gauge, the dial on the UTM. Then maximum load we can read, then divided by 2 into area of cross section. Why? Because of these two resisting area. So that is the only calculation included in this. So the procedure is like the calipers that you have to measure the diameter. Now determine the area of cross section of the specimen, pi square by 4. Now since we have to set the UTM, calculate the expected maximum load. So we have to assume an maximum shear stress for the specimen, say let it be 5000 kg per centimeter square. Then into 2 into area of cross section will give you what is the expected load on the UTM. So if we are getting a load which is less than 3 ton, 3000 kg, we can select the area 0 to 3 ton. If it is greater than 3 ton but less than 10 ton, we can take 0 to 10 ton. Otherwise, we go 0 to 30 ton. Accordingly, we have to set the range. So you have seen how the machine is set for the different ranges. Now select the range and adjust the UTM. Then keep the specimen in the shear shackle. So this shear shackle arrangement is video. So I will explain then. So the specimen shear shackle is the arrangement for fixing the specimen in which the end positions are held down and the center portion will be allowed to shear off. So that arrangement is called the shear shackle. Then keep the shear shackle set up the UTM and load it. Now note the maximum load, P ultimate. The calculation include, first of all, the range calculation. That is, assume an ultimate shear stress of 5000 kg per centimeter square for the mild steel specimen. Maximum expected load is equal to 5000 into 2A. Now select a range. Now P ultimate will be obtained from the reading. Then calculate the shear strength of the specimen as the knotted measurement of the P ultimate, then divided by 2 times the area of cross section. So that's all about the shear test. Now we shall pass on to a video which describes how the test is conducted.
So I'm here to demonstrate the double shear test experiment. So we performed this experiment on the universal testing machine, tension test, deep bending test. So requires a certain apparatus.
Is the video visible for you?
Ma'am, the video is
Yes,
visible,
ma'am.
but take more time for loading the video. I think some because net issues, just not visible
Visible.
clear.
Okay.
That's all the issue,
Then
ma'am.
not yet started. I just not
Okay,
yet
ma'am.
started. You tell me whether it is properly visible or not. Okay.
Yes, it is.
I'm here to demonstrate the double shear test experiment. So we perform this experiment for tension test, bending test, debending test, etc. So our experiment requires a certain apparatus, a test specimen, test rig along with the eye plate.
So this arrangement is called a shear shackle. See how it is kept. First of all, diameter measurement, then keeping it in the shear shackle. That you can see.
Diameter is the diameter of the test specimen. So we get the diameter as 11 millimeters. We note down the diameter. Next, we use this diameter to tabulate the area of the test specimen. Next, we need to set the range for this universal testing machine. So this range is determined by first assuming our area, assuming our shear strength as ultimate shear strength as 300 megapascal, and the load, required load to be set onto the universal testing machine is equal to the load load P, which is equal to the shear strength into twice into area of our test specimen. So let's assume our area to be A, and let's assume our area to be A, and we have our Fs, which is the ultimate shear strength, as 300. So thus we compute that required load that is to be set in the universal testing machine. So let's assume our load was computed as 78 78 megapascal.
Not,
So,
so the
78
unit is actually kilonewton, 78 kilonewton.
For 78 kilonewton falls in the range of 0 to 120. So there are a set of 4.
So accordingly, so this calculation you need not worry. We are assuming the maximum stresses 5000 kg per centimeter square, then into 2 into area of cross section that you do, then you will get the expected maximum. Then accordingly, we have to select the scale on the dial to read the load.
Counterweights behind the machine. We set the counterweight which is equivalent to A plus B, which is equal to 60 plus 60, which is equal to 120 kilonewton behind the machine, as shown.
The range setting for this machine is different. So this is called the shear shackle. See here how the specimen is kept. The specimen is first of all kept inside. Then see on the two edges we are keeping two rings. So this is the portion where the load is applied. Okay. So this arrangement is called the shear shackle. And this is to be kept in the location where compression test is conducted in the UTM. So in this case, the middle one is moving down and applying the load. So this is kept at the lower portion. For our machine, we are keeping the specimen on the middle portion where we are applying the load in the upward direction and it is compressed.
As you can see, we have set the test specimen over here. Now we lower the middle crosshead such that it touches the thus it now touches the test rig. So now we switch on the machine. slowly release the control.
Now the specimen is fair. Now the red needle, from the red needle or we can read what is the maximum load that is reached. So this maximum load you read from the dial, then that will be in kg or ton as it is obtained from the UTM. Then divided by 2 into area of cross section will give you the stress in kg per centimeter square. Then you can convert it Newton per mm square. So this machine is giving the value in kilonewton. That is why they have written like this. So this is the calculation. So that's all about the machine. So the part that is not familiar to you is the shear shackle. Once again, you can see how the specimen is kept in it. This device is the same as that we are using.
So now we switch on the machine. And slowly release the control.
That's what the experiment. If you have any clarifications, please ask regarding the experiment or anything else.